proofs. And I told you that the strategy I wanted you to use is we pick a side and we box that side in. So that's essentially our goal. That's what our answer should be, and we will keep working the other side until we get there. So which side do you want to box in? They're both kind of ugly. I'm going to box in the right because it's harder to turn something into a fraction in general, I think. So if one side's a fraction, one side's not, I'd rather try to simplify the fraction. Okay, thoughts? Come in.
Are you sure?
Yeah. All right, so what would we do here?
Change tangent to sine and cosine.
All right, so that would be sine squared s over cosine squared s. And secant we could change to
1 over cosine.
So, some of us, I know, have kind of struggled with this. When we are dividing fractions, I gave you guys some tricks to try to simplify that, but if you get stuck, all it means to divide fractions, just like in algebra, is flip and multiply. So the top one stays the same, times, and then you flip the bottom one. So we're multiplying by our reciprocal. What happens when we do that? Cosine squareds drop. And we get sine squared s. All right, look at our goal. We are trying to turn this into 1 plus cosine s times 1 minus cosine s. Okay? How?
Easy method.
So we just have sine squared s. We're trying to get cosines.
Sine squared is the same thing as 1 minus cosine squared.
Yes. So if you look at that, our formula, it's the Pythagorean identity, that main one that I've said over and over again, we're going to keep using. Sine squared theta plus cosine squared theta equals 1. We know we want cosines in here because of my goal. So if I look at that, sine squared, if you subtract over, is the same as 1 minus cosine squared. And then AJ said factoring. Didn't we do a difference of squares problem when we were factoring yesterday? So 1 minus cosine squared, we know difference of squares factors into two things, one with a plus and one with a minus. 1 would just work into 1, cosine squared works into cosine s. So 1 plus cosine s times 1 minus cosine s. And we've got it. Make sure your notation is good. I'm looking for, make sure you're boxing in one of the original sides. Box in your final answer, so those two boxes should match. You're showing me all the work along the way. Another option that we're going to look at sometimes today, sometimes you might get stuck on one side. Maybe you got to sine squared and you couldn't figure out how to get to here. Another thing that we can do is actually work both sides and get them to simplify the same way. So what I recommend is probably working down on your paper instead of working over. So that way if you get stuck and you have to go work the other side, you can make a second column for that. Does that make sense? And so if I had gotten stuck, let's say I worked this one and I could not figure out how to get sine squared s into this, then what you would do is just say, okay, I'm going to box in my sine squared. Now I'm going to come work this other side and try to turn it into sine squared. And so we had to multiply these, so that would be 1 minus cosine squared s, which is sine squared s. And then you would box in both of those, so the two boxes match. But if you do that, the columns help a lot so that you can clearly see you are working both sides of the equal sign and getting them to the same place. Okay, so that's going to happen. Sometimes you might get stuck. You might have to jump ship and go work the other side, and you're just trying to get it down to the same point. Any questions there? So we're just going to keep trying some. not necessarily a right or a wrong. That's why the work is your answer, because you might do it different ways. What do you want to do with the left? Okay. So tangent t is sine t over cosine t. Minus cotangent t is cosine t over sine t. Divided by thoughts. This is really over 1, right? So if I want to divide fractions, we flip and multiply. Times, I'll put that on 1 over sine t. We have to distribute this. So I have sine t over cosine t. If I take it times 1 over sine t cosine t, what's going to happen? The sines would cancel. The cosines would be multiplied. So cosine t times cosine t would be cosine squared t. Does everyone see how those signs cancel out here? So on this one, what's going to cancel? The cosines, and you have 1 over sine t times sine t, which is sine squared t. Look at our goal. I'm not trying to get a common denominator here. I want these two separate things. What is 1 over cosine? What's the reciprocal of cosine? So that's secant squared t minus the reciprocal of sine is cosecant squared. And that's what we want. So we're done. Right here. Okay, so when I multiply, I have sine times 1, which is sine. Cosine times sine times cosine. So the cosine times cosine became cosine squared. Okay. Any questions? Just keep trying them. Make sure you're speaking up if I lose you on one. So from here, there really isn't one side that's obviously easier than the other. So we're just going to pick one and box it in. It's really not going to matter. So let's say I box it in. All right. We always look for any obvious formulas. Are there any here? No. Then we always change things to sines and cosines. It's already sines and cosines. So we're kind of lost. I mean, I could split this up and say 1 over cosine plus sine over cosine, but if I look at my goal, I'm trying to keep a fraction, aren't I? So breaking apart my fraction is probably not going to get me where I'm trying to go. We also know, we've done it a few times, where as long as you multiply the top and the bottom of the fraction by the same thing, that's a legal move. Because if it's the same thing on top and the bottom, it's like multiplying by 1. Look at our goal. We want a cosine and we want a 1 minus sign. Look at what we have. What do you think I should multiply by? 1 minus sine. We don't have it in here and we need to get it somehow. So let's just say I decided I want to multiply the top and the bottom of this fraction by 1 minus sine x. So on the top, you would have to FOIL. So 1 times 1 is 1. Minus sine x and plus sine x cancel. Sine x and negative sine x and negative sine squared x. I am not going to distribute on the bottom because my goal is to get a 1 minus sine x on the bottom. And we have that, so I'm just hoping I can get that cosine to disappear. So I'm not actually going to distribute that out yet. Any options from here? One minus sine squared x is cosine squared x. Does this help me?
Because the square on the top cancel, bottom cosine will cancel.
Yeah, you can cancel a single cosine out of here. And so then we're left with a cosine x on top and a 1 minus sine x on the bottom. And that's what we wanted. I'm going to do a few more. I think I'm actually going to skip my next example. I won't do this one. So this is our example 6. Any ideas?
I feel like we can box in the left side,
Okay.
and then on the right side we can split them.
All right, let's try it. Worst thing that happens, if we get stuck, we can always come back and work the left as well and see if we can get them to the same point. So, what are we going to do over here? Okay. So you said split it. Are you meaning factor? Is that, or were you putting each one over the denominator?
Like putting each one over the denominator.
Okay. So we have 2 different suggestions on the table. One of them is to break this apart and do like cosine squared over negative sine squared, negative 2 cosine theta over negative sine squared theta. So break them apart like that. The other is to factor. How would you factor cosine squared theta? Yeah, we could do the box method on the top. So both valid options, not obviously one over the other. That's going to be helpful here. What should we try? You want to try box method? Let's see how we do. So cosine squared, we'll just break into cosine theta. I need two numbers that multiply to positive 1 and add to negative 2. Negative 1 and negative 1. Okay, on the bottom, negative sine squared theta. Can I change that to anything? We know that in general, sine squared theta plus cosine squared theta equals 1, right? So sine squared theta is 1 minus cosine squared theta.
So could it be 1 plus cosine?
It would be
Negative.
negative 1 plus cosine squared theta. Or I could write that as cosine squared theta minus 1. Can you factor cosine squared theta minus 1? We could do a difference of squares there. So that breaks into cosine theta plus 1 and cosine theta minus 1. What happens?
One of them will cancel and the other one will turn into.
But because it's not a square, we can't use the identity. So we get to here. Look at our goal. We're not too far. We want something minus something on top, something plus something on the bottom. So we're close. Does anyone see how we can get there from here? If we're stuck, what can we do?
The other side.
Okay. We can say, okay, never mind, this is going to be my new goal because I don't know how to get here. So I am going to work the other side of this equation and try to get to that answer. So if I work the other side, what could I change cotangent theta to? Minus cosecant theta is 1 over sine theta divided by cotangent theta is cosine theta over sine theta minus cosecant theta 1 over sine theta. We have a lot of fractions here. What do you notice? Oh, yes, thank you. So one trick we've seen is it's okay to multiply the top and the bottom of the fraction by the same thing. What might we want to multiply by? I would do sine theta since it's on the denominator of all 4 of these little fractions. So then sine theta times cosine over sine would just be minus sine theta times 1 over sine theta plus 1 sine theta times cosine theta over sine theta cosine theta plus sine theta times 1 over sine theta plus 1. And that matches what we got on the other side. So if you get stuck, doesn't mean you're wrong, doesn't mean you have to give up. You just go start working the other side and see if you can get it to the same point. Okay. I want to give you guys time to work in class. I know we've had some this week, but not tons. I'm trying to give you a little more time today so that you can ask questions when you're getting stuck on things. So, maybe really page 203, I don't know exactly what page the first problem starts on. We are going to do